This is a potter's kick wheel. You sit on here, there's the wheel, underneath the wheel head there's this shaft going down to this larger disc here which you kick. Like so, and that then powers the wheel head up here, which is the metal bit which a pot is thrown on. So I thought I'd try and demonstrate what a real Foucault pendulum, how a real Foucault pendulum should work. First of all, it should be stationary. If it's going to detect any movement in the earth. So that's the earth, the wheel head, and the sun is over here. When you're going spinning that way on the inside of the earth, you're going 1,000 miles an hour slower because you're going that way, but now you're spinning that way at 1,000 miles an hour, so you've got to take 1,000 miles an hour off the direction that you're going in the other direction. And then when you come around to the other side, here, you'd start to speed up by 1,000 miles. You're going to be slingshotted around again because you're going 1,000 miles an hour faster until you get to here again, and then you're going 1,000 miles an hour slower. So there's going to be a difference. So when you go slower, look what happens. You know, there's all this movement, because that could represent you, the kind of movement you would feel as you think your life is doing all this. Just have a look what sort of thing would happen. So I'll be speeding up slowly. In fact, you know, I can't. Like, it's impossible to speed up. But when it gets going, it does get quite smooth. Right, that's you. That's what a Foucault pendulum should be showing you. Should always be swinging out to the side as you're going around the earth like that. Now it's gradually coming back into the centre as it's slowing down. But that's not what's going on. What's going on is it's suddenly slowing down because it's suddenly going this way. I cannot move the potter's wheel this way. So this is stationary. This is what happens if it's stationary, but you're also going this way. So that's not what's going on. But even then, look what a Foucault pendulum should be showing you. Added to that, I'll show you what happens. I'll try and demonstrate what happens if I slow the wheel down and then speed it back up again. You know. So, but before that, this is what they do with the Foucault pendulum: is they start swing it. They bring it up here, and they start to swing it. So now they're starting to swing this while the earth is turning. So let's have a look what it should show you then. So they're going to start to swing this like this, then the earth starts to turn. Yeah, it's all over the shop. So eventually it gets up to speed. Alright, now when it gets on the inside, tangled mess. I don't think, you think you're living on something like that? Man. When I'm slowing it down then, that's representing it moving this way. I'm taking the speed off, so it's now going a bit slower. So perhaps we can do this in slow motion and explain it a bit more clearly. So you're coming around here, now you're going slower because you're also going this way, so that's going to create a swing this way because you're now going slower. Alright, and then when you come around to here, 6 o'clock, you're going to go 1,000 miles an hour faster because you're going with the flow, with the direction of the Earth. You're going to be slung around here really fast. You're going to start going ahead. And then when you get to here again, you're going to start slowing down again because you're going 1,000 miles an hour faster. And then when you get to there again, whoosh, you're going 1,000 miles an hour. And I think you're going to notice that, and this Foucault pendulum would demonstrate that. It wouldn't just show that it's swinging like this, and after 24 hours it starts moving a little bit and changing directions and going, really, how it works. If anything, that demonstrates that the Earth is stationary because there's such little going on with the Foucault pendulum. See that again, is it? Because it's fun. This is your crazy ball Earth. What a load of bollocks.